Here we're asked to solve or evaluate each of these logs. Basically, it's just asking, hey, what's in that question mark spot? And if it's not possible, then we can just explain why. So first one here for A here, I'm going to change this around because I know that if I have a root, that is the same thing as a fractional exponent. So really I'm going to change this to e to the power of 2/5 because since it's squared and then it's fifth rooted, it's really the same as the exponent of 2/5. And that's just one of my exponent rules that I should know. And so to figure out what this is equal to, I'm going to go ahead and call this x just to make it a little bit more familiar. Whenever I have the natural log of e, that means that the base of the log and the base of the exponent are the same, and therefore they cancel out and leave me with just 2/5. So for this first one, it's just 2/5. For the second one here, for b, similar idea of like how we're going to solve this. So I really just want to get to having the log base go away or the log go away. So if we have log 3 of 1/3, I'm going to raise both sides to a base of 3 because that will cancel out this log and leave me with 1/3 equals 3 to the power of what? And then I just know with my exponent rules that I have to make it a negative exponent to make this into a fraction. So in this one here, I know x is equal to -1. For the third one here, we got log base 5 of 625. And I'm looking for, again, we're going to call it x. I raise both sides 5 to the power of each side to cancel out that log. And now I know, I believe it's 5 to the power of 4. Let me just double check that with a calculator really quick. 5 times 5, yep. Looks good. So in this one here, I know that x is equal to 4. And now if we keep moving on here to d, so we got d here is log base 3 of 0 equals what? Raise both sides to a base of 3. Oh, those cancel, sorry. 0 equals 3 to the power of what value? And there is nothing that would change this into 0. So there's no exponent that would make that whole thing equal to 0. If I plugged in 0, it would be 1, but remember exponential functions kind of have an asymptote where we can't have that y value be equal to 0. So this one here is impossible. For e, looks like the natural log of what equals 7. I'm going to raise both sides with a base of e to get rid of that natural log. So x is equal to e to the power of 7. All done with that one. And then f, our final one here, is log base 5 of what equals 1/2. And so I'm going to raise both sides with a base of 5 to cancel that. And just to, again, make it look like something that we recognize, I know that the exponent of 1/2 is the same thing as a square root. So that's how we solve each of those different log equations.